So let me explain a little bit about how McSAS3 works. The model intensity that McSAS3 uses is composed of a number of individual contributions, typically about 300 contributions, and this can be of any shape that you like. But for simplicity's sake, let us choose the sphere for this example. So we have 300 of these things, and what the Monte Carlo procedure then does is it takes one of these, it replaces it with another random sphere of, sphere of a random size, and it checks whether this actually improves the match between the measured intensity and the model intensity. If this is not improved, then we reject that particular option and we put the original back in place. If, however, one of these replacements does indeed improve the match between model and data, the replacement is kept, and so we iteratively improve the set of contributions that we have. This looks a little bit like the following. So in the central part of this slide, you see this set of objects. So that set now defines the model intensity, shown in red. The measured data is shown in yellow. And this set can also be interpreted to form a size histogram, right? In this case, a volume-weighted size histogram. So when we let the optimization run, you see that many of the objects in the initial set are being gradually replaced. You see the improvement in match between measured intensity and model intensity, and you see the effect on the size histogram. Now, you might be a little bit surprised how we can get away with only 300 contributions for size distributions that could actually be very broad. And that is because of a peculiarity in the small angle scattering data. Now, the information content in scattering data is close to a volume-weighted information. So this wouldn't really work if you would just add your form factors together, because as you know, it's not just the form factors that you're adding, but you're also weighing them with the square of the volume with the square of the volume of each one of these shapes. So that means if we were just adding form factors, that the larger sizes would absolutely dominate the scattering pattern, and you would not see anything of the smaller sizes. So in order to compensate for that, we are volume weighting, right? So we are, in this case, dividing by the volume of each object. And that means that we now actually form not a number-weighted distribution, but a volume-weighted distribution. So there's, in this probability P, there is actually a volume factor hiding in there to compensate for the division by the volume that we do at the end of this equation. So keep that in mind. So we can now simplify this equation so that we only have the form factor times the volume of the object, and that this allows us to have scattering from small objects appear at approximately the same intensity as the scattering from large objects, but we need to keep in mind that the distribution that we get out is a volume-weighted distribution. The second limitation of this is that you can only use form factors that specify a volume. So if you're looking through the SAS models library and you find something like a fractal model or a Poirot model, these do not have volumes specified, and therefore they cannot be used by McSAS. So objects with a specified volume you can, others you can't. So that is one of the limitations of this approach, but it does allow us to get away with very, very few contributions. And I hope that helps you understand a little bit more about the underpinnings of McSAS3. Now, it might be interesting to note that the simple acceptance rejection algorithm, it seems a bit well, crude, and it is, right? It is very much a brute force method. But over the years, I've tried to make it smarter, right? I try to make the random number generator a bit cleverer in how it does things. And all of the attempts that I had done on to try and improve the cleverness of the algorithm have not resulted in any improvement. Indeed, they deteriorated the performance of the algorithm. So there may be better ways of doing this, but for now, this is a reasonably good method. So if you have any questions, as always, please feel free to contact me. And otherwise, good luck with McSAS.